Hello people of the world. I thought I'd previously done a video on proteins and I mentioned the spike in coronavirus. I thought I'd explain what the spike's actually made of. It's a protein, but I thought I'd elaborate and talk about what proteins are made of, but I've not really mentioned that at all. So I mentioned in previous videos the two big helices. That's the alpha helix, and you get with hydrogen bonds join them together, okay? And you get hydrogen bonds join these together as well. So there's a beta sheets. I mentioned that in previous videos. The spike I mentioned has 1,273 amino acids. Okay.
Accurate atomic model of the Sars coronavirus virus. Sorry, the Sars coronavirus structure. As you can see, you've got these fluffy spikes that each little dot in it ball represents an atom, okay?
And I mentioned previously that amino acids are joined together by peptide bonds, okay? So it's amino acid, they're all linked together, okay? But what are amino acids? Well, they're acids, and they've also got these amino groups as well in them, okay? But what makes them particularly unique and what gives them each specific property, I'll put that a different way, there are a total of 20 amino acids, okay, we get through food, okay, and each one is different. Each one has an acid and an amino group, okay? The acid being C, okay? Well, you can write that as C, okay? And the amino group being NH3 plus, okay? Forget that dot, so it's plus. So that's the amino part and that's the acid part, okay? Normally you write and draw an acid like C when it's not lost to hydrogen, but that's when it's lost to hydrogen, okay? So, but this isn't actually quite what makes the amino acids, that's just how we name them. We name them by the amino group and the acid group, the carboxylic group and the amino group. But what I want to show you is the actual, each of the amino acids in turn. I actually was inspired to do this bit by, in the film, you probably heard of the film 2001, A Space Odyssey. Okay, there's also a sequel, 2010. When I first saw that as a child, when I was about 10, they mentioned amino acids in it. And at the time I was given a childhood sense of wonder because I didn't have a clue what amino acids were. So I thought I'd draw out amino acids for you to show you what they actually are, okay? So, excuse me, so I've drawn out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? The basic, the NH3COO groups here, they form the peptide bonds. The circle groups, these are the actual, each of the side chains that make each amino acid specific. So glycine is basically hydrogen, alanine's a methyl, valine's this V shape coming off the methyl, coming off a single hydrogen. Then you've got leucine is this, and isoleucine is this part. This is proline. Phenylalanine, so that's a phenyl group, a benzene attached to what is basically a methyl, okay, of alanine. That's tyrosine, and so on. So, and you've also got a lot of these groups are hydro. This is obviously the smallest one, single hydrogen. These groups are all hydrophobic, which means they do not dissolve in water. So they'll be found inside proteins, okay? These will be found in hairpin turns and loops. A lot of them, these will be inside proteins. Some of them are very bulky, like this, proline, and tryptophan is exceptionally bulky, okay? Some of them have sulfurs in, cysteine and methionine. Okay, so there's sulfurs there. You also get some of them are, again, yeah, these ones are also to some extent hydrophilic. They dissolve in water as they form hydrogen bonds. At least that one will a little bit. These will also form hydrogen bonds because of the hydroxide group. Okay, so these are hydrophilic. The amino acid serine, okay, that is the actual section of it, the actual active group of serine, okay, so hydroxide with 2 hydrogens on it. Sorry, carbon in the middle, hydroxide and 2 hydrogens either side. Threonine is that section, which is, I didn't mention earlier, you got hydrogen, methyl group and hydroxide coming off the central carbon, okay? So that's why it's kind of called threonine. I remember it as being 3. It's not really 3, but it's pronounced the same way as number 3. You got 3 different groups coming off the middle carbon, hydroxide, methyl, hydrogen. They'll be found outside, on the outside of proteins where water is. On the inside of proteins there's no water, on the outside there is water. And then you get ones which are basic. Then you got lysine, so yeah, the basic amino acid is lysine, okay, so that's the whole of that, okay, NH3 plus in the end, 4 CH2s running up, and then arginine, which is this. So that's 3 CH2s and then nitrogen and then carbon double bond nitrogen, sorry, NH2 plus and then NH2 here. So this has got 2 NH2 groups, 1 positive charge, double bond carbon to nitrogen here, okay? So that's arginine. These again will form hydrogen bonds, and they're found the outside of proteins. These are actually found in histones. They're DNA wrapped around. These are often on the outside of our chromosomes and so on. Anyway, yeah, you get basic ones, and then you got acidic ones as well here, glutamate and aspartate. And then if you take the amino acid derivatives of these, sorry, the amino derivatives, so if you replace this with NH2, you get asparagine and glutamine, okay? So you're replacing the O negative with NH2, you get this, which is asparagine and glutamine, okay? For the record, this is these are primary amines, okay? So if you have NH2, that's an amine group. That's a primary one, okay? Then if you have basically NH like that, that's a secondary. And if you have yeah, you have, that's a sorry, tertiary amine, okay? So that's primary and the secondary, and then that one, okay? Tertiary, so that's got 2 hydrogens, 1 bond on 1 hydrogen, no hydrogens, okay? So that's basically, these are amino, these are amino acids because they've got the O negative replaced with the NH2, okay? So these are amine ones. Primary amino acids. And then quickly wanted to mention this at the end, which I didn't go quite enough before. So you got this whole thing is actually the cysteine, okay? That's the cysteine. And with methionine, it's the whole of this section, okay? So the whole, that's methionine. And the cysteine is SH at the very end. Methionine is the sulfur just before the methyl group, okay? The way they form is you get if you get two okay, so you get so if you get, say, you might get alanine like that, and that, I'll just draw glycine, okay? Make it simple. So those would come together, and what you do is you end up with these form a peptide bond, which is like that, okay? I'm not going to draw this endlessly, but to give you an idea. Okay, so you got CH3, which is the alanine group, and you got hydrogen there, which is so that's the alanine, and that's glycine, okay? So that's how this is joined together. You get these peptide the peptide link here. This is a condensation reaction. Okay, so you get what come off that? H2O. I think it's water coming off. You get water coming off. Okay, you get suddenly an oxygen being lost there, and hydrogen is being lost, so it's water coming off. Okay, condensation reaction. So yeah, that's kind of that gives you an idea of how they join together. Or if I could go on more extensively, and you got so here you might have alanine, okay, and you might have here, hold on, yeah, that's valine, okay, and what does tyrosine look like? Just remind myself a little bit. So you could have so here you could have C. So that would be an example of that'd be alanine, and then that'd be valine, and that would be the one called that's serine, okay? So that's an example of how they all link together. Alanine, valine, serine, and you get hundreds, thousands of amino acids all joined together. And put the pair of electrons in there for the fun of it. A lone pair of electrons. So thousands of amino acids joined together to form a big protein. Could be a ribosome, could be an enzyme, could be a actin in your muscle. It can be anything, but they all get linked together, and you could get multiple alanines in a row or multiple serines in a row, but they all get joined together like this. Okay, so that's what the amino acids are and their role in proteins. So yeah, I hope that helps. Have a good day.